Welcome to the Chapter 3, Section 1 lesson video. Today we're going to talk about something called graphing polynomials. Now this is realistically one of our first completely new topics. It is different. It is a little tricky. I'd encourage you to take out your notebook, get ready to take some good notes, and get some questions prepared for our next live session. All right, so we're going to graph polynomials. We're going to be able to identify a polynomial function, and we're going to learn how to graph that function. We're not going to be using a table. We're going to use these polynomial functions in what's called factored form, and so we will have to talk about something called the zero product property first. So here we go. Here's the zero product property. It says if A times B times C equals 0, what can we logically conclude? Well, we can conclude that either A equals 0, B equals 0, or C equals 0, or any combination of them equals 0. So if some amount of things multiply to equal 0, then we can conclude that one or all of those things equals 0. Based on this logic, we can go ahead and say if this parentheses times this parentheses times this parentheses equals 0, then one or all of these parentheses have to equal 0. So let's figure out what x could possibly be if that's the case. Either x minus 3 equals 0, x plus 7 equals 0, or 2x minus 3 equals 0. If the first one's the case, then x will equal 3. If the second one's the case, then x will equal negative 7. And if the last one's the case, then we're going to add the 3 over. 2x equals 3. Divide by 2, x will equal 3 over 2. So here we go. For this equation, we have solved for all the possible values of x that will make that equation equal 0. We're basically saying, what can I plug in for these different x's to make each parentheses equal 0? All right, so what we can do is we can use that property to help us find the different intercepts on a graph. So we're going to do a couple things. The first thing we're going to do when we get a big old polynomial equation, these are polynomial equations here, the first thing we're going to do is we're going to let y equal 0. If we let y equal 0, then we can find all the x-intercepts. So we'll say 0 equals x minus 3 times x plus 5 times x minus 2 times x plus 1. Then we'll go ahead and we can either write them all out separately or we can kind of think through them. What can I plug in here to make it equal 0? What can I plug in here to make it equal 0? What can I plug in here? What can I plug in here? These are all our possible x-intercepts. So our first one, what minus 3, is positive 3. Our second one, what plus 5, is negative 5. Our third one, what minus 2, is positive 2. And our last one, what plus 1, is negative 1. These are all of our x-intercepts. So let me change this a little bit. These are our x-intercepts. Awesome. Now, the y-intercept, we've been doing this for a while. A y-intercept is a little bit different. When we want to find our y-intercept, we're going to go ahead and make x equals 0. So what that means is we're going to plug in 0 for all of our x's and then see what happens. So I'm going to plug a 0 in here, a 0 in here, a 0 in here, and a 0 in here. That'll leave me with negative 3 times 5 times negative 2 times positive 1. If I multiply that all together, negative 3 times 5 is negative 15. Negative 15 times negative 2 is positive 30 times 1 is 30. So my y-intercept for this equation is positive 30. Awesome. So using this zeros, these zero methods here, we can find the x-intercepts by making our y value equal 0 and figuring out each of the parentheses, or we can find our y-intercept by making our x's, all of our x's 0, and then multiplying what's left over. All right, the last thing we're going to do is we're going to talk about how these polynomial graphs are going to start. Now, normally in a lot of stuff that we do, we start on the left side. But with all of these graphs, instead what we're going to do is we're going to start on the right side. We're going to start with what's called the end behavior. Now, the leading coefficient of a positive is going to determine the end behavior. So if we go back and we look at all the values in front of all the x's, if the product of all of those is positive, then our graph is going to start on top or above the x-axis on the right side in some way. So it's going to be coming down from the top right. If we look at all the leading coefficients from all of the factors and their product is negative, then it's going to be coming from below in some manner. So a positive leading coefficient, or a positive in front of everything, is going to be coming from on top. A negative, or the product being negative of everything, is going to be coming from below. And we're going to see some examples of this in a second when we do a couple practice graphs. So really what we're going to be looking for is three things. We're going to look for the x-intercepts, the y-intercepts, and then the leading coefficient is going to tell us whether we're starting on top on the right or on bottom on the right. All right, so let's go ahead and let's practice. We're going to go ahead and we're going to graph this polynomial equation. Now, just a heads up, these graphs look a little crazy. They're going to kind of look like roller coasters. Ooh, they're going to do this like squiggly thing. They're going to have a bunch of x-intercepts. They're going to have a y-intercept. And these are all things we're going to look for. So our steps go like this. First thing we're going to do is find all the zeros, all the x-intercepts, by making y 0. Then we're going to find the y-intercept by making all the x's 0 and plugging that in, multiplying it out. Then we're going to find the leading coefficient to determine whether we start on top or on bottom on the right side of the graph. And then lastly, we're going to kind of connect it all up and draw a nice little squiggly roller coaster. All right, so let's go ahead and begin. So step 1, I'm going to do this in purple. So step 1, I'm going to do in purple. I'm going to find the x-intercept, so I'm going to say 0 equals x minus 3 times x plus 5 times x minus 2 times x plus 1. All right, so what minus 3? My first x-intercept is positive 3. What plus 5? My second one is negative 5. Minus 2 is positive 2. Plus 1 is negative 1. These are my x-intercepts. All right, my next piece, my y-intercept, I'm going to do in green. So I'm going to plug in 0 for all the x's. So that's going to become negative 3 times positive 5 times negative 2 times positive 1. If I calculate that all out, it tells me that my y-intercept, so that was all the x's are 0, just multiplying what's left over. It tells me that my y-intercept is negative 15 times negative 2 is positive 30. For my y-intercept, positive 30. And then the last thing I'm going to do is I'm going to go through. The leading coefficient here is positive, 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 positive. So a positive times a positive times a positive times a positive. My leading coefficient is positive. So that means when I graph this in just a second, I'm going to start on top. All right, so we can now graph. So what we're going to do is we're going to draw a graph. We're going to kind of draw a nice long x-axis. We'll draw a y-axis in here. And then we're going to remember that this graph is a sketch. It doesn't have to be to scale. So the first thing I'm going to do is I'm going to mark up all my x-intercepts, and I'm going to label them. So my first x-intercept is at positive 3, so I'll go right here and I'll say that's positive 3. My next x-intercept is at negative 5, so I'll come over here and I'll say this is negative 5. Then I have an x-intercept at positive 2, so I'll come right here and I'll say this is positive 2. And then my final x-intercept is at negative 1, so I'll come over here and I'll say this is negative 1. All right, my y-intercept is positive 30, so I'll go on the y-axis up top and I'll say this is 30. Obviously not to scale, but that's okay. Last but not least, I know that I am starting on top of the graph because my leading coefficient is positive. So when I draw my graph here in just a second, I know I'm going to start somewhere up top here. All right, so here's what we do now. We have all of these things marked, but what you can do is you can kind of think of all of these little dash marks on our graph, 3, 2, 30, negative 1, negative 5. You can kind of think of them as little doors. At these dash marks, I can go from one side to the other, but I can't go through anywhere else. So what I'm going to do is I'm going to start on the top side. I'm actually going to erase this little blue blurb right there. I'm going to start on the top side, and I'm going to go down to my first door. So I'm going to go hit my first door, go through, loop back around, hit my next door, come back up, hit the 30, come back down, hit the last door here, and extend my line with an arrow going off to infinity on both ends. All right, if you need to go back, if you kind of covered some stuff up, you can go back and you can say, all right, well, this was a 3 right here. This was a 2 right here where it went through. This was a 30. This was a 1. And this was a -5, just to make it nice and clear. But we can clearly see that the graph starts on top on the right, comes through the x-intercept of 3, hits the next x-intercept of 2, hits the y-intercept of 30, x-intercept of -1, x-intercept of -5, and goes off to infinity. All right, our second example here, I'm going to do a little bit quicker, hopefully, and you can follow along. Our x-intercepts, we'll look at the equation. What makes the first parentheses equal 0 is a +1. The second parentheses is a -4. The third parentheses, be careful here, this is a +2/3. +2/3 will make that equal 0. And the last one is -1. All right, we look and we plug in 0 for all the x values. That'll give us -1 is +1. +1 times 4 is 4. 4 times -2 is -8. Times 1 is -8. So our y-intercept this time is -8. And then lastly, we look through all our leading coefficients, positive times a positive times a positive times a positive, a negative. So our leading coefficient this time is negative. So we'll go ahead and we'll mark all the different things on our graph. We have a x-intercept of 2/3. We have an x-intercept of 1. We have a x-intercept of -1, and we have an x-intercept of -4. Remember, not to scale, but in the correct order is what we need. We have a y-intercept of -8, and then our leading coefficient is negative, so we know we're going to start on the underside of the graph. So we start on the underside of the graph, we go up, we hit our first intercept, we turn around, we go through our second intercept, we keep going, we go through the y-intercept on the y-axis, come back up, hit our next intercept at -1, and then go up as much as you want, and then come back down and hit your last intercept at -4, and put arrows on both ends. There's 2 last things we need to pay attention to, and these are special cases. On these special cases, certain things are going to happen. So the first special case is a bounce. So if you ever have a parentheses squared, what's going to happen at that intercept is a bounce. So I'm going to come to that intercept, and rather than crossing through to the other side, I'm going to bounce off and stay on the same side. So we'll go ahead and we'll do this real quick. We'll say our x-intercepts are -1 for the first parentheses, and then the second parentheses gives us 2 +2s. You have to list them both. So 2 and 2. Our y-intercept, we plug in 0 for all the x's. That's 1 times -2 times -2. Our y-intercept is +4. So that was 1 times -2 times -2 again, because of that squared, is +4. Our leading coefficient is positive, and so we can mark up our graph. So we have -1, we have +2, our y-intercept is +4, and then since it's positive, we're going to start on top. So this is what's different here. When I come to that 2 intercept, rather than crossing through the doorway, since it was squared, I'm going to bounce off. So it's kind of like, since there were 2 of them, I come and I hit it, and I go through it and go through it right again, so I stay on the same side. Now, usually you want that to be a little more curved than what I did here, but that's okay. So we keep going through, we hit 4, and then we come down. This time there's only 1, no bounce there, so we're gonna go through to the other side. All right, so if we have a parentheses squared, it's what's called a bounce. So it'll hit the intercept, but it won't go through to the other side. And then lastly, if we have a parentheses cubed, so this time it's a parentheses to the 3rd power, rather than bouncing off the intercept, we're going to have what's called an inflection point. So this is sort of that cubic shape that we've seen in other graphs, where it kind of curves in one side and out the other in a different direction. So you're going to hit the axis or the intercept, and you're going to go through, but you're going to kind of do a little inflection-y curve wherever that point is. So we'll go real quick. We'll get the x-intercepts. So our first x-intercept is -1, and we actually have 3 of them. So -1, -1, -1. You list them all. And then our last x-intercept is a +4. Our y-intercept, let's see, so we have a +1 to the 3rd power. So that's 1 times 1 times 1 is 1 times -4. So our y-intercept is -4. And then our leading coefficient is once again positive. All right, so we have a -1, and this is where that inflection thing will be, and I'll try and do my best with it. And then we have a positive intercept on the x-axis of 4, and then a y-intercept down here of -4. All right, our graph is going to start on the top side this time. I'm going to go through 4. There was only one of them, so I go straight through. I'll come down, I'll hit the -4 on the y-axis, and then as I come through right here, I'm just going to do my best. I'm going to try and curve it one way coming in, and then curve it the other way going out. It's not always perfectly visible, and realistically, the important thing is that you go through that point. So what you're going to notice is 2, if you have an exponent of 2, it bounces off, but if you have an exponent of 3, it still goes through, and do your best to kind of draw this little inflection-y curve where it kind of curves one way and then curves back out the other way, kind of like our cubic graph would. With that, you should have enough information to be able to get started on our assignment. I would encourage you to take a look at it before class. I will go over some more examples and answer plenty of questions, but until then, have a great day.